Hello, welcome to PH Maths. Number in focus on root 5. Root 5 is the surd inside the golden ratio, the diagonal of a 1 by 2 rectangle, and the hidden engine behind every Fibonacci formula. By the end of this video, you'll know how root 5 connects Pythagoras to phi, where it simplifies out of root 20 and root 45, and why it deserves a place in your surd shortcut list. Quick identity check. Root 5 is positive. Root 5 is irrational. Root 5 is algebraic. It solves x squared equals 5. And as a decimal, it's approximately 2.23607. 2.23 is a useful working value for sense checking. Root 5 sits just above 2 and just below 2 1/4. That gives a quick mental sanity check. Multiples of root 5. Root 5, 2 root 5, 3 root 5, 4 root 5. The same surd rule as always. K times root 5 equals K root 5, kept in radical form. Don't expand, don't decimalize. The exact form is the point. The moment you decimalize, you've lost the link between root 5 and the golden ratio, which is half the reason root 5 matters. Powers of root 5. Root 5 to the 0 is 1. Root 5 to the 1 is root 5. Squared is 5. Cubed is 5 root 5. Fourth is 25. Fifth is 25 root 5. Same pattern as every surd. Even powers are integer powers of 5. Odd powers tack a root 5 on the side. The structural rhythm holds across every square root surd. Inside the golden ratio. The golden ratio, written phi, equals 1 plus root 5, all divided by 2. That's roughly 1.618. Every Fibonacci style calculation uses phi, and phi is built directly out of root 5. Binet's formula, the closed form expression for the nth Fibonacci number, uses root 5 in both the numerator and the denominator, so every Fibonacci number ultimately runs through root 5. Key relationships. Root 5 squared equals 5. Root 5 is roughly 2.236. Phi equals 1 plus root 5 over 2, which is roughly 1.618. Root 20 equals 2 root 5. Root 45 equals 3 root 5. Root 125 equals 5 root 5. And the diagonal of a 1 by 2 rectangle is root 5, straight out of Pythagoras. Where root 5 shows up in your exam, simplifying surds like root 20, root 45, root 80, root 125. The golden ratio, phi equals 1 plus root 5 all over 2, appears in higher tier surd questions. Pythagoras on a 1 by 2 right triangle gives a root 5 hypotenuse. Quadratics with a discriminant equal to 5 produce root 5 surds in the answers. And diagonals of rectangles with 1 to 2 side ratios. Where root 5 hides, anywhere you see root 20, root 45, root 80, root 125, that's a hidden root 5. Inside phi, 1 plus root 5 over 2. And Pythagoras on a right triangle with legs 1 and 2 gives a hypotenuse of root 5. Spotting any of these cuts your working time in half. Right, if any of this is going to stick beyond this video, drop into phmaths.com. You'll find a free 4-week GCSE Higher revision planner ready to download, plus the mastery workbooks. One for every higher topic, every answer fully worked, every common slip flagged. Simple explanations, serious results. See you next video.